There we go. Okay, cool. Right. I guess we had a Shiny session, and now we have a special data session, in some sense. I will be talking about what kind of special data you bring for this one here. So this was titled Survival Analysis is Coming to Tidymodels. I am excited about this, no kidding. But I am also very happy to say that actually it has been released like a couple of weeks ago. It's out, it's on CRAN. You can download it, you can do things with it. And if you're like, okay, but like I don't do medical research, like why do I need survival analysis? Let me rephrase that for you. Tidymodels can now deal with time to event data. And that's the type of special data that will be part of this talk here. And that event can be pretty broad. Like it does not have to be death. It might be like an employee leaving, or a machine needing repairs or replacement, or it could be like time until a shelter animal gets adopted. Like it's pretty broad, but sometimes people don't quite recognize it as the type of data that it is. And I'll hopefully let you see that a little bit today. And the reason that I'm so excited about this, apart from me having worked on this for quite a while, is that I do think that Tidymodels is a pretty darn useful tool. And survival analysis is a really cool useful tool. So now to be able to like use them in conjunction, pretty good. So basically, this talk has two parts. One is like, why Tidymodels? And the other one is, why survival analysis? So let's back out just a moment and be like, what the heck is Tidymodels? It is a framework or a collection of R packages for modeling and machine learning using tidyverse principles. And I think part of the, or a big reason for the success of the tidyverse is how relatively easy it is to use. And that is not an accident, that it's a result of careful design. What the functions are named, how they work together, that you like have this thing of piping things together that a lot of people are pretty familiar by now with. And if you are comfortable with that, then Tidymodels is a way to do modeling in that sort of idea and style. And our sort of guiding principle for all of this is that we want you to be able to focus on the modeling question and not like the sort of extra hurdles of the tools. Like the tools should be easy so that you can spend whatever brain power you got left that day on picking a good model, a fair model for this. And, not get bogged down in like syntax details because you have to remember what that argument was called in that package that you're going to go try next. And maybe you then go have to change your whole data from a data frame to a matrix because that's what the next thing that you want to try needs. So the other part, oh, I did not refresh my slides, cool. I wanted to change this from like data spinning to like not focus on like the infrastructure of empirical validation. So not having to like try to guess what the next argument name or function name is. You also shouldn't be too bogged down in resampling your metrics properly, like making sure you don't have data leakage. These kind of things are part of the infrastructure for you to do modeling. These are part of the things that we provide. So for example, we have an object called a workflow, which bundles your preprocessor and your model into one thing. That's the thing that where you may need to estimate components of. So you should do that estimation on sort of the training set and the training set only, right? So these kind of things are provided by Tidymodels in what hopefully feels pretty natural. So that you can go think about what type of model you want to be using. And obviously for that thing to be useful, it should cover quite a broad spectrum of the infrastructure. So these are the hex logos are for parts of the core packages matched up with what's above it. So our sample is for resampling. Everyone's favorite cupcake is the logo for recipes, which is preprocessing. Parsnip is for the models. Blame Max Kuhn for that name. And yardstick for measuring things, and tune obviously for tuning strategies. So that's covering sort of the core of this idea of empirical validation of your models. But this alone obviously doesn't cover everything. And so these packages are designed to be extensible, and we've done a bunch of this. So most of this is sort of in the middle with like Parsnip for different model types all over the place, but you also have recipes, extensions, for example, text recipes package to be able to pre-process your text data. And if this is not enough, also special shout out to the spatial sample package for spatial resampling. Obviously, that's quite a bit, but it may not be the specific thing you need. But we're not the only ones who can extend that stuff. And I'm going to be very curious how quickly that slide loads, because it should show you a frame of a website. Our website, tidymodels.org. Oh, we're coming. Cool. Under the Learn section, in sort of the developer tools tag, are a bunch of articles that tell you how to extend these core components if there's anything that you need that we haven't done yet. And if you open an issue on GitHub telling us where you got stuck, we're usually able to help. So that's sort of Tidymodels, helping you do machine learning and statistical learning in a sort of safe and sound way, and extensible. So that's fun. But we were talking about special data, and the question remains, why survival analysis? And for that, we'll just look at a data set, right? The first bit of code, it just shows you this customer churn data set. So the first column is the tenure, how long somebody's been a customer with that company. And the second one is churn, basically whether they've left, whether they've stopped being a customer. And then a bunch of predictors. And you might get asked questions that you're supposed to answer with this. Maybe it is, how long is somebody going to stay as a customer? Calculate something like customer lifetime value. For that, you kind of like need to know the lifetime, right? Or somebody is like, who is likely to like churn soon? Who's likely to stop being a customer? So let's try to look at these with some like standard tools. First up, how long is somebody going to stay as a customer? Well, sounds like a regression problem, maybe, sort of at the first glance, right? So you take that tenure variable, the time, and you make that your response. But that time here, that is the observation time, right? That is not necessarily time to event. There's no notion of event if you just take the tenure. And if you say, well, but I'm going to interpret this as time to event, then you're implicitly assuming that everything is an event at the end. And that might not be true. What we actually have in a lot of cases is more something like this. Like on the bottom one, that longer one, that's somebody who we observed from start of being a customer until they left. That's the solid dot. The other two have like a not solid. What is that? Opposite? Well, anyway, so these two, you haven't observed the event of them leaving yet. They're still customers. That's not the same. So if you just sort of assume that they have left, you're underestimating how long they might be staying. You could try to wait until you observe all the events. That might not go down well with people who want answers. You might be tempted to just ignore these because you haven't observed an event, but you're going to bias your analysis with this as well. So kind of most ways we look, this doesn't feel extremely comfortable, right? You might be modeling a different question than you actually set out to do. You might make wrong assumptions. You might waste information. Like, none of this is what fills you with joy, I would say. So let's park that, because also the regression model doesn't help you answer the other question, like, who's likely to stop being a customer? Okay, maybe that is a classification problem, right? So we just look at the event status. Are they still here, or have they left? And you're just like putting the time aside. Well, you are putting the time aside, but it doesn't go away, because this isn't like who is likely to stop being a customer. This is who is likely to stop being a customer while you observe them. Like, you cannot really get out of this one. So if you just use classification for this, you ignore that aspect that you've observed somebody for potentially much longer than others, and somebody who just started being a customer yesterday is a different kind of information than somebody who started last year. So also, doesn't fit like a glove, right? Obviously, where I am going with this is pretty obvious, but just sort of stating another obvious thing, like time to event data inherently has two aspects, the time and the event status. And if you don't observe the event yet, that's called censoring. And incomplete data is not missing data. So that is a qualitative difference, and you need to deal with it differently. And if you go and try to shoot at this problem with a regression or a classification model, you're always only modeling one aspect, and you need two models to answer those different questions, and you're not really properly accounting for the other aspect. You might get close, but you might not get there. And there's tools that are made for exactly this, so you might as well use them, especially if it is easy to do so. So survival analysis is like the thing that you're looking for here, and it can simultaneously take into account if something happens, sort of the event status, and the time or other continuous outcome until that event. And just to like tie back to this morning when Colin was like, speakers lie. I'm not lying, but like, speed over things? Heck yeah. So after this sort of motivational thing about why you might want to use survival analysis, let's draw the whole owl and fit one of these models rather than deduct like how this exactly works. So going back to that customer churn data set, the first thing I'm going to do here is combine the tenure and the churn status into what we're going to use it as our response. That's like a serve object. That's the standard data format in R or class for this. And because that's our response, we're going to do this before we do anything Tidymodels, because that is sort of the recommended way to like just do that first. And then we're going to split the data. That is hopefully all function names that make it very clear what's happening. That's the initial split. You can pull out a training and a testing set out of that object. And we are not going to do the whole shebang. Let's start with one model. But we are going to do a tiny bit of pre-processing to show you how that works. So that's a recipe, because you sort of like write down instructions of what to do with the data and then separately go apply it to potentially different data sets or versions of it, resamples of it. And that one here just has a single step to it that is removing variables that have zero variance, because they don't tell us anything, and sometimes models strip up. So that's the pre-processing part, our recipe. The second part is a model spec. And in Tidymodels, they have three components: the model type, what you're going to use it for, the mode, and what you're going to use to actually fit the thing, that's the engine. Survival reg, pretty specifically for censored regression, but this could have also been a decision tree, and you can use that for a regression problem or a classification problem, and there you would actually really need to say set mode censored regression, because it's so flexible. And then we're going to put these together in a workflow, and then we can work with that thing as the thing that we fit and predict with. So let's do that on the training set. And now we can go make some predictions to help answer the questions that we had. So how long is somebody going to stay on as a customer with like a survival model? That would be your median survival time. And you can say predict on this thing and set type to time, and then you will get that type of prediction. So that's like the numeric one. And the other question we had of who is likely to stop being a customer, we're going to estimate something sort of like flipped. We're going to predict survival time, survival probability, rather than like event probability. So in this case, the number is like a probability for somebody still being a customer in the next instance. But a probability like that, survival probability, is always calculated at a point in time. Like overall time, survival probability is 0. The event is going to happen. That's the basic assumption. But like before that, it changes. So here we have the last argument eval time. That is 12 months and 24 months. So we're going to get actually 2 predictions, 2 predicted probabilities for these 2 time points. And we very consistently adhere to the tidy principle that one row is like one observation. And that's why this one row in here has a little tibble in it, a 2x2 tibble. But one row is always like corresponds to one row that you put into new data. So that's why this doesn't show you any numbers just right now, but you can look into it. And this customer, you don't need to be particularly worried about. Their survival probability of still being around as a customer after 12 and 24 months is pretty damn high. So that's good. And that's kind of like the warm-up of showing you you can answer very different questions with the same model, and to not just like talk poetically about Tidymodels and the design philosophy, but show you some syntax. And I'm going to like fill in the gaps a little bit here about what specifically we have in Tidymodels for that type of analysis. So there are models that can deal with that kind of data as a response. There's parametric models, semi-parametric models, and tree-based models available for this. The prediction types are particular to that. So you've seen the 2 main ones, survival time and survival probability. Some of the models give you other types of predictions as well, like the hazard. And for a parametric model is the linear predictor. And those 2 things have been out for a while. What we've now fairly recently added are metrics for this. Again, if your response is like this combination of time and event status, you're not going to get far with like standard classification or regression metrics. However, some of these metrics have a survival version. So all of these listed here are ones that have sort of like a non-survival correspondent thing. So you probably heard of like area under the ROC curve and things like that. So, but these here are survival-specific versions of them. And having these was sort of the piece that made it possible for us to unlock being able to tune these kind of models, because without any performance assessment via metrics, no tuning, pretty obviously. And that makes it able to be like, whoa, here is the Tidymodels hex sticker, just sort of trying to tell you that it is the whole framework now works for this. we done a bunch of changes to tune under the hood that you probably won't really notice. You shouldn't really notice unless you need a particular thing. But that means you can take these models and you can leverage all of the other goodies that we've put into Tidymodels previously. Like if you have, say, text data, and you can use text recipes to do that when you're pre-processing, tokenize it, whatever you need to do, and then use those as an input to survival models, and sort of then go and do grid search by racing or something like this. So like you get all of the other stuff, quote, for free now. And I think that combination of things is the thing that gets me excited, why I've worked on this for quite a while. So happy to say that. And if you do want to see some of the things in between, it was like, that was too much glossing over details. We've put a bunch of articles on tidymodels.org. There's a case study that lets you see this in more detail, including tuning and sort of looking at performance metrics and all that stuff. There's an article that dives deeper into the metrics. And then really, if you really want to know the details, you can dive into that third one where we talk about the nitty-gritty details of how we account for censoring in these types of data. And that's it from me. Thank you.